Welcome to the lesson on section 4.6, Graphing with Calculus and Calculators. As an example, let's sketch the graph of f of x equals 2x to the 6th plus 3x to the 5th plus 3x cubed minus 2x squared. It wouldn't be that hard to find the derivative of this function by hand. However, if you'd like the calculator to do this work for you, here's how you'd enter it in the calculator. We would enter the function in y1, and we would use the nderiv function in y2. If you have the newer operating system, selecting nderiv from the catalog will print the derivative using Leibniz notation for you, like this. Instead of using the catalog, you can also press alpha F2, and you'll see nderiv in the menu. You'll need to enter x's in the first box and last box, and a y1 in the middle box. And again, a quick way to get y1 in the new operating system is alpha F4. Then graph the derivative, which I have in y2, and you'll use second trace 0 to find the critical values. I got negative 1.616, 0, and 0.352 as the zeros. Mark a sign chart with pluses and minuses to show where the first derivative is positive or negative. Then do the same thing for the second derivative. Again, if you have the new operating system, you can use alpha F2 to find nderiv in the menu, and then use alpha F4 to find the y2. Fill in x's in the first box and the last box, y2 in the middle box. Be prepared for this to take a long time. The calculator doesn't find the derivative of the function and then just graph that equation. It's calculating each derivative point by point. Here's the first and second derivative information we just found. There are relative minima at negative 1.616 and 0.352 because of the decrease on the left and increase on the right of these points. There's a relative maximum at 0 because of the increase on the left followed by a decrease on the right. Both negative 1.233 and 0.193 are points of inflection because the concavity changes sign around them. Again, you may find it helpful to write a short summary of each interval. I even draw myself a little key on the side to show what the different combinations of increasing or decreasing with concavity looks like. Since this is a calculator question, you can use your calculator to find the coordinates of the intercepts, max-min points, and points of inflection. Then just draw the graph section by section. Here's what mine looks like. This concludes the lesson on section 4.6, Graphing with Calculus and Calculators.